So we started working with inverse functions on, well, it's been 2 days, on Tuesday. Bless you. And we're going to continue on it with it today. And the first one we're going to find is we're going to find the inverse of f of x equals x squared, comma, x is greater than or equal to 0. Now, it is a restriction on what we can have. Now, part of the reason we have this restriction is, well, if we look at the graph, clear both of these out, and it was x squared. I think it was x squared, not 2x squared. X squared. If we look at this graph here, we get a parabola, because we knew it was going to be a parabola because of x squared. Now, can I draw a horizontal line and cross that graph twice? Well, yes. So when they set the restriction of just x is greater than or equal to 0, it meant that anything on this side of the graph is not being included. We're just looking at the right-hand side for where x is greater than 0. So none of this here is included. So we do have all positive values, yes? And when we talked about this on Tuesday, we said when we find the inverse, we're really switching the x and y values, the domain and range. So the domain for the inverse is going to become the range, and the range is going to become the domain. And when we look at all these values, well, for this here, the domain for x squared is positive, and the range is positive, because they're both going up. So that means when we switch them, well, for the inverse of it, the domain would still be positive, and the range would still be positive, because they're going to flip. Does that make sense? And I'll bring that back around here in a minute. So let's go on and find its inverse. So what that means is we're going to start off with replacing f of x with y. And then what would we do next? Y'all remember? We don't square u yet because we have once we switch x and y. Because when we find the inverse, our first step is to rewrite f of x as y. Switch x and y is our second step. And now we would solve for y by square rooting both sides. Now the square root and square with y cancel out, giving us y is equal to plus or minus the square root of x. Because when we square root both sides, we include the plus or minus. And then last but not least, we rewrite y as f inverse of x is equal to plus or minus the square root of x. Now, there's a reason I showed you the graph and kind of looked at how the graph of our original function looked. Because our original graph, and I can draw it back in here, really was this here because we didn't have the other half. Yes? Now the domain, the x values for this are positive. The range, the y values are positive, yes? So when I switch it, well, for the inverse, the values that are going to plug in are going to be positive, because that would be the range. The range for f of x is the domain of f inverse, because we flip them. Yes. And what comes out is going to be what? That's where we're having to deal with this here, this plus or minus, because all the values have to be what? So could they be negative? No. So what that means for us here is that we don't actually have the plus or minus. It's just f inverse of x is the square root of x. By our standard operations and what we do, because we square rooted both sides, we need the plus or minus, but we don't need it because we're restricted this function to only being greater than x. And what this will look like is they're going to start here, and it's going to go this way here. Now, if we had included the negative side here, its inverse would have gone this way here. If we would have included it. But as we can see there with the red and green graph, that does not pass the vertical line test, so it's not a function. But our inverse is this here. It technically wouldn't have an inverse. It technically wouldn't have an inverse, but I would still have you go on and find it. We would just leave the plus or minus there. Huh? Thank you. I haven't been outside that much. So how do we feel about these here? Yeah. Yes. So, questions, how do y'all feel about the overall steps for finding the inverse? Not so much the plus or minus and whatnot, but the overall steps of actually finding the inverse. We feel good with that there? Because the most part, it's just really, we rewrite, so here, I would rewrite it as y equals x squared minus 2. Yes? And then what would we do next? As, and the y as. Mm-hmm. Yeah. And now we solve for. Yes. We would, but we wouldn't do it first. Yes. Mm-hmm. Because we would add it since it is subtracting already. Mm-hmm. But we would move the 2 first. Because when we do square roots, or especially square roots, we want whatever we're trying to reduce the power or get rid of a power by itself first, or as by itself as we can get it. Because the unfortunate thing with the minus 2 is once we square root it, they're gonna be stuck. Now, if it was a set of parentheses squared or a set of parentheses, if we had it say y minus 2 squared, yes. Because then the square root and the square would cancel, and we've got the variable out. But here, unfortunately, it wouldn't cancel it out because these 2 would be stuck together. Now, if it had been minus 4, well, y squared minus 4 is a difference of perfect squares. So we could factor it, or try to factor it, or there's different ones we could use. I realized difference of perfect squares wouldn't work because the factors wouldn't be the same. It would be y minus 2 and which is not a set of parentheses squared. It's two different ones, so that wouldn't work either. Does that kind of make sense? Okay. And now, we would square root, which would tell us that our square root of x plus 2 would equal y. Yes. F inverse of x is equal to, we would say plus or minus normally, but we just have the square root of x, because in the directions it told us x is greater than or equal to 0. So since x is greater than or equal to 0, here we would not have the plus or minus. Yeah, it still works. Really, I don't like that phrasing, x squared is greater, x is greater than or equal to 0. Well, it does work for this here. But for the inverse, really, we need x to be greater than or equal to 2. Now, you don't have to include that in there. The reason I'm stating that is because, again, we're switching the domain of f of x is going to the, let me see here, to the range. Our function takes those values from the domain to the range. Yes? Now, if you look at that there, for x squared minus 2, if x is 0, we get negative 2. Because 0 squared is 0, minus 2 is negative 2, yes? So at the smallest value for this here, we have 0 going to negative 2, yes? So when we switch it for the inverse, we go this way. Okay, so it's fine. Because that's what I was worried about, is having this negative number in the range going back out, because what do we have at the end of our answer? The square root. And we don't need a negative in it, but negative 2 plus 2 is 0. So we're good. So questions on this here? Because I thought that was going to be an error because of negatives, but again, I looked at it, I checked it, I tried plugging it in, and it worked out, it's fine. So sometimes it's good to work out those thoughts. But any questions on any of this here? Let's look at this one here. So consider the function f of x equals 2x cubed plus 1. Determine whether the inverse is a function, and then find it. Well, the easiest way to determine if it's a function is to just graph it. I think it's 2x cubed plus 1, yes? And this here is the graph. So if we look at this here, does it cross, can I draw a line and have it cross more than once? Well, no. It looks like it at the y-intercept it could be, but it's actually just increasing at a very, very small amount. So this here passes the horizontal line test. which means it does have an inverse. It does have an inverse. And we can find it. Equals 2x cubed plus 1. Yes, we'd have 2y cubed plus 1. We switch that x and y. And now what? Yes. Should give us x minus 1 equals 2y cubed. Divide by 2. Because we still want to try to get y as by itself as we possibly can. And luckily, dividing by 2 is not a bad step. This gives us x minus 1 over 2. And then, yes, now we would cube root it. Which would give us y by itself is equal to the cube root of x minus 1 over, since it's in odd root, it wouldn't be. Odd roots don't have it, but even roots do. Some might say it's a little odd. Yeah. It's easy to flip it if we're not paying attention.
I'm sorry, I'm having a very...
Friday?
It's a Friday.
So questions on this here. So we are starting to feel comfortable with this here, because a lot of this here isn't so much new, it's just we're working through our steps of solving these equations for a variable, our literal equations. Okay. So on this one here, we're going to do a different function than what's listed there. So you can still use this page. Yeah. Negative fourth root of 7x plus 3 over 4. Let me rewrite. It is going to be easier than what you might think.
Why did you do it in the square?
It's the negative is really out front. So it's really a negative fourth root of 7x plus 3 divided by 4. So let's just go through the steps that we've been using. Negative fourth root of 7x plus 3 over 4.
Wait, you do 7 plus 3?
Yeah, so then we would switch it.
Minus 3 or plus 1?
Well, unfortunately, the 3 that's next to the 7y is also being affected by the division and the fourth root. So we have two things in front of us, so we have to get out of the way. Now the negative, we can divide, let's multiply both sides by -1. Because it's going to be good to get this to be positive, because that would give us negative x, get the same color. Negative x is equal to the fourth root of 7y plus 3 over 4. Now, since it's an even root, it's going to be a mute point. But if it was an odd root, it would be necessary. So what do we need to do to both sides? Since we have a radical. Because how can I get rid of a fourth root? I have to put both sides to the fourth power. Because a fourth root and fourth power will cancel. Which on this side here will leave me with 7y plus 3 divided by 4. And we have negative x to the fourth. Because anything to an even power, negative to an even power, becomes positive. So we just have x to the fourth. And that's why I was saying, since it's an even root, the negative moving it didn't make a difference. Because once we took the fourth power to both sides, it goes away. What can we do next? So, yes. We're going to multiply both sides by 4. Because really, when we multiply this by 4 over 1, we'd have a 4 in the numerator and denominator. So they would cancel. Over here, we're going to have 4x to the fourth equals 7y plus 3. So any questions on how we got to this point here? Just a lot of manipulating this equation, yes? Now what's next? Yes, we would minus the 3. Would give us 4x to the fourth minus 3 equals 7y by 7, yes. Now, there are restrictions we could tap to, or kind of if we wanted to look into seeing what they were. I'm not going to worry too much about that side of things and the restrictions and how we'd go about finding them. And I'm not going to make you find them. Because what we'd be really doing is looking back at the original, back to the top, this function here, the original starting function, and saying, what is the smallest value of x that I can plug in here and not get a negative number? Because that would be the domain, if we were to find that. And if we were looking at that there, it would be -3/7 would be the smallest value that we could have. And the reason I'm saying that is because to simplify the 7 times 1/7 is 1, yes? And if I have a -3 on top, -3 plus 3 is 0. So it's just, we would have simply put whatever's inside there equal to 0 and seen what that value is, which would tell us that here x has to be greater than or equal to 3/7. And then we could find our range from that. And again, as we said, the range and domain switch. So here it's saying that y is going to be less than or equal to 0. So when they switch, it would tell us that our new one, the domain would be less than or equal to 0, and the range would be x is greater than or equal to that there. But I'm not worried about y'all being able to pick that up and do that here. Okay? Well, that's essentially what we just did, but to just another level. Yes? Do y'all want to see this one here? Yes? Because we can look at it. So what do we do first? Two times the square root of x minus 3. Yes. And now we need to get y by itself. So what would be a good first step? Because we want to get the radical by itself first, since it contains the square root. So it'll be good to get it by itself, having these cancel. So we'd have x over 2 is equal to the square root of y minus 3. Now what would we do? We put both sides to the second power. Because the square root and square would cancel. So we'd have y minus 3 is equal to, so we can square the numerator and denominator. We can apply it to both. Well, x squared is x squared. 2 squared is 4. Almost. Plus the 3. Questions on any of this here? How do we feel about these here? Feel comfortable with it? And I think doing some on your own is going to help with these here. So I'm going to skip ahead to this here. This is the last part of the chapter that we are going to do. Now, it says that we need to verify that these are inverses, yes? So I'm bringing composite functions back, the ones that we did on Monday, okay? Because we said the composite function is taking f, we plug f into g and g into f, yes? Well, with inverses, if they are inverses, well, the function f takes it from the domain to the range, and the inverse takes it from the range back to the domain, yes? So if these two are inverses, they will give us the exact same thing if I take f of g of x, and if I take g of f of x, is if I do the composition function both ways, they will give me the exact same value if they are inverses. So we're going to look at f of g of x first. Well, our g of x function is x plus 1 over 3. Well, that's not a bad place to start. And then we take this here, x plus 1 over 3, and plug it in for, which would be 3 times x plus 1 over 3 minus 1. Any questions on how we got to this point so far? Now, there is something nice. Well, they would cancel out because really we would multiply the numerator, which would give us 3 over 3, and they cancel, leaving us with x plus 1 minus, which is equal to x. Okay. Let's look at g of f of x. Well, f of x is 3x minus 1, yes? And if I plug it into g of x, well, that would be 3x minus 1 plus 1 divided by 3. Any questions on this so far? Well, since there's nothing being multiplied outside those parentheses for 3x plus 1, we just drop it. And I'll write that out because we'll have 3x minus 1 plus 1 over 3. Well, the negative 1 plus 1 become 0. They cancel out, yes. Which leaves us with 3x over 3 and 3. Simplify out, they cancel out. So f of gave us what? And g of f of x. So doesn't this mean that f of g of x is equal to g of f of x, which is equal to x, yes? So both of these gave us the exact same thing, yes? Yeah. So that means f of x and g of x are inverses. So the only way that the composite functions where we can flip them, f of g of x and g of f of x, we can flip them like this, and they give us the same thing, is if they are inverses. Because again, the inverse, when I plug something in to the function f of x, it takes me to the range, and when I take its inverse, it takes it from the range back to that input. It brings me back to where I start, yes? So when I plug it into g of x, it took me to the range, but when I plugged it back into f of x, it took me back to the domain where I started. That's why we're getting x, because it's bringing us back to where we start. Questions on this here? So we understand this? Yes? And there's an interesting reason why it is x. So we had 3x minus 1 was our one function that we just tested, yes? And g of x, alpha y equals, so these here are our two functions. So we have that one there and this one here, yes? And they cross. And when we took f of g of x and g of f of x, we got x, yes? Do they mirror straight across that line? Yeah. It works out. Clear. We did x squared to start with today. Clear. And we found that its inverse was, I'll do both, second square root of x. And really, if we had the whole thing, I'll do purple, negative square root of x, because if we had the plus or minus, flip straight over there. That's why we're getting x, because it's really a reflection across that line, y equals x. And that's kind of how we get these inverses. They're always across this line. So questions on this here?